Good morning, everyone. Welcome back from spring break. This is Mr. Duenas here. I just want to quickly show you the parent notice that I sent over Aries, and also I posted up on Google Classroom, so you guys can go ahead and see how the class will work out. But just to summarize very quickly, want to make sure that we have access to Google Classroom. We have all the videos that I post up, and the videos and the notes will be posted just like before, just like I did in class, after class or after the day. And so please expect to have notes, video links, and whatnot for you to use as resources. And there will be assignments given to you that's homework that's going to be due by Friday, each Friday. The questions will be due. And so if you do need any help at any time, feel free to reach out again by using Google Classroom, email, and I'll get back to you guys as soon as I can. And then also, I do want to make sure that to let you know that um, please fill out the welcome back survey. This is how I will be taking attendance and keeping track if people are doing what they're supposed to be doing. So please make sure that you fill out the welcome back survey today. And then again, I'll be available throughout the school days, normal school hours. But please reach out if you need any assistance with anything. Okay. All right. So for today, I'm gonna go ahead and get started. I will be posting up more instructions and whatnot in terms of notes. For today, we're going to talk about and introduce Learning Target 9A. So as you can see, Learning Target 9A is about writing arithmetic sequences with an explicit formula or rule, and then we're going to use them to model situations. So one more time again, we're going to go ahead and write arithmetic sequences with an explicit formula, which is also known as the rule, and we're going to use them to model situations. Okay. So our first vocabulary word is sequence, right? A sequence is a function whose domain is a set of consecutive integers. So again, it's a function whose domain is a set of consecutive integers. Now, sequences don't have to go consecutively all the time. So you'll notice in some of the questions that we're going to pose later, you're going to see that they're not always going to be consecutive. The first example is to introduce it. So please keep that in mind. As a note, we're going to be talking about a different kind of domain. So if the domain is not specified within a sequence, then it always starts with 1. And I'll give you an example shortly on that. So again, if the domain is not specified, then it starts with 1. The terms, there's something called terms. The terms are the values of the range. So the terms, if you think about an example here, we have the domain. So the domain is considered basically the sequence. And so these are the relative positions of each term. For example, we have 1, 2, 3, 4, and then that means it keeps going all the way to the nth number of times that the sequence continues. So it's going to go on forever, in other words. And then we have the range. The range is basically A1 is like the first digit of the sequence, A2 and A3, and so on. So as you can see, it goes on for a while. So A sub n, and these are called the terms of the sequence. So that's with corresponding to the range. All right. So again, one more time, the domain is the sequence. Basically, it usually starts with 1, but it doesn't have to start with 1. And then we refer to the range as A1, A2 for each digit that we have in the sequence. Then we can go ahead and classify them A1, A2, A3, A4, and so on. Okay. All right. Now the finite sequence that is going to be given to you is a sequence that has a limited number of terms. So what does that mean? Well, basically that means that if you have like this example, a sequence of 2, 4, 6, 8, that means it stops. It doesn't continue. Notice there's no like dot, 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 just like the domain up here, and it continues forever to positive infinity. So in this case, this one right here is basically the infinite sequence is a sequence that does not end. And so, for example, you have 2, 4, 6, 8, comma, dot, dot, dot. Okay, so we're going to be doing that. And finally, we're going to be doing equations and rules. So both sequences above can be described with the rule a to the n equals 2 times n, or f of n equals 2 times n, because notice that you go from 2 to 4,